This is the second part of lesson 3.2. So we're going to start off this part of the lesson with just a little story problem about Superman. So it's kind of an older movie, but if you know anything about the movie, it says, well, an overactive fault, an earthquake swallows up his love interest, Lois Lane. Ignoring the fact that he'd likely kill everyone on the planet, Superman decides to use his ability to fly to zoom around the planet. He figures he can turn back time and prevent the death of his girlfriend by flying concentric circles. Concentric means that they have the same center. So if you have one circle that goes around that center, another one, they all have the same center. That's concentric. So concentric circles around the planet, reversing the spin of the Earth, making time move backwards. This would not work and would be a stupid plot for a movie. So, by the way, if you want, I will attach the link to the video right there. You can fast forward through it if you don't want to watch it. Kind of an old movie and we've come a long ways. But anyway, it also says to use 3.14 for pi. So the radius of the Earth is about 3,959 miles. So radius of the Earth. So think about the Earth from the center to the outside, 3,959 miles. Assume that Superman flies to a height where the atmospheric pressure is weak enough to consider it the start of outer space. So we're going to have this circle that is the outer space circle, so he's going to fly to this much. It's roughly 50 miles above the surface of the planet, so we've got another 50 miles on top of the radius, so 3959. And so that's how far out, that's the radius of the circle that he's flying. So that's 4,009 miles is the radius. Okay, so we're going to approximate the distance that he flies around the planet to the nearest whole mile. So we're just talking about one circle around the planet. So are we looking for area or are we looking for circumference? Hopefully you recognize we're looking for the circumference of this circle. And so we're going to say 2 pi times r. Okay, and so you're going to calculate that. It does say to use 3.14 for pi. And so when we do that, how many miles would he have to fly? He would have to fly 25,176.52. Oh, nearest whole mile, so we're going to say 77 miles. That's a lot of miles to go around one circle around the Earth. Suppose he flies around the planet 30 times before the Earth came to a stop. How far did he travel? So you're obviously just going to do that 30 times. And that's 755,310 miles. That's an insane amount of miles. So it would have to be Superman, I guess. Okay, so it says Superman drops his girlfriend off at Quito, Ecuador, which is located, I don't think this really happens in the movie, which is located on the equator. So if we think about the equator, it's at the very center, like right there. Okay, so I'm just going to put Quito, Ecuador right there. To cover an important story for her newspaper. Then he flies to the North Pole, so the North Pole is going to be right up here. To stop Lex Luthor from melting the ice caps in an attempt to drown all the residents of all coastal cities on the planet. So how far does he have to fly to go from there to there? So that's not going to be the entire circumference, it's just going to be a fraction of the circumference. So if you're going from the equator to the North Pole, how many degrees is that? Okay, so I'm looking at a fourth of the circumference. So since I already figured out the circumference right there, because he's not flying like on the surface of the Earth, it's going to have to be above. So I'm just going to do a fourth of that I found. Okay, so that's approximately, and again I'm using 3.14 for pi because that's what it said to do. If I used the pi button, it's going to make a more significant difference on this because we're dealing with such big numbers. Okay, these last few questions are kind of turning the problems around and finding an unknown. So we're not given the radius, we're going to have to find it. So you want to make sure you can do these types of problems too. So this says the area of the sector is 20 pi feet squared. So 20 pi is my area, and it's equal to 72 out of 360 of pi r squared. So this part of it, I know that that's how I find the area if I knew pi, and this is what I would get. Since I don't know pi, I'm going to set up this equation and I need to solve for pi. So I'm going to leave the 20 pi there. 72 out of 360. So since I'm going to be doing decimals anyway, I'm just going to put that in my calculator. I get 0.2 for that, so 2/10 of a circle, a fifth of a circle, and then pi r squared. When I have that, I'm just going to divide by pi and just get rid of pi. Okay, that makes it nice. 20 is equal to 0.2 r squared, so now I'm going to divide 20 by 0.2. And so that's going to be a bigger number, 100 equals r squared, and so r is equal to 10. So if the area of that sector is 20 pi square feet, the radius has to be 10. Okay, number 17. The arc length of DF is 30. So the arc length is the fraction of the circle times 2 pi r, and I don't know r, but I do know that the whole thing is equal to 30. So 10 out of 36, I'm going to leave it as a fraction. So 2 goes in there 5 times and 18 times, so I just hate getting decimals in there too soon. So 5 times 2 is 10. 10 divided by 18, so we're going to have 5/9 pi r equals 30. And so remember how we solve something like this, we can multiply by the reciprocal. Okay, so then the 5's canceling, the pi is canceling, 9's canceling. I'm left with r is equal to 30 times 9 divided by 5 pi. And so using the pi button, you're going to put that in your calculator. So I'm going to have 270 over 5 pi. So that's going to give me 17.19, so 17.2. And in this problem, we're talking about meters. And so it's going to be meters squared because it's saying, oh, sorry, we're finding the radius there. That's the radius. Okay, check and see. That wasn't the question. What is the area of the circle? So the area of the circle is going to be pi and then r squared. So 17.2 squared. That's going to be a little bit off because I'm using a rounded number for it, but there's not a lot I can do about that. I mean, there is, but I'm not going to. So that's approximately equal to 928.9. The reason I said I'm not going to is I've got so many numbers here that are, I'm keeping significant digits. I didn't round right up there when I could have. I kept pi all the way until they were at the very end right there, so I kept it really close, and so I just have this one rounded number. If I wanted to, I could go back and say, do the 270 divided by 5 pi again. I mean, I am using 3.14 for that. I could write 17.19745 and get a little bit more approximate answer for area. So I went back and did that, and if I get 928.66, so 0.7. So it's really close. If we had a test question like that, where you could round for pi there and then you use rounded answer and round it again, I would have a margin of error on that. So anyway, it's just kind of, you got to be really careful, but at some point there has to be some leeway. Okay, last problem there. The area of the small sector is pi, and so this right here, it's just pi square inches, so about 3.14 squared inches. So the fraction that I'm looking at is 40 out of 360 times pi r squared, and it's equal to pi. So if I go and simplify my fraction, 4 out of 36, that's 1/9 pi r squared equals pi. If I divide both sides by pi, I'm going to get 1/9 r squared equals 1. So multiply both sides by 9, and r is going to equal 3. So r equals 3. So the question is, what is the circumference? So it's 2 pi times r. So 6 pi, which is approximately equal to 18.84. and that's in inches. If you're interested, I'm going to put a link to the video clip of Superman turning back time. The movie was made, I think it was in the maybe late 70s, early 80s, and so you can see what movies used to look like. Kind of fun to see it.